In order to explain how truss works, I must first talk about internal forces. Even if I try to explain its function as clearly as possible, I unfortunately cannot avoid introducing the theory behind it. So, what are internal forces? They are the forces that result in a body from an external load and are in balance with it. My explanations should not be too theoretical in this video. If you're interested in background information, you only have to carry out an internet search for Newton's laws. Newton's laws can be easily explained with this apple. This apple has a certain mass which generates a downward force when multiplied by acceleration due to gravity. My hand must apply an equal force against it, which keeps it from moving. So the action of the downward force is equal to the reaction in my hand. It is therefore a static system. When I generate a smaller force with my hand, the apple moves down. When I generate a larger force, it moves up. This turns the static system into a kinetic system. Let's return now to internal forces. In other words, the reactions within bodies. Basically, there are three different types of internal forces. First of all, we'll talk about normal force. If I apply a longitudinal force to the end of this cuboid, it will be compressed. This means that the inner reaction is a compressive force. When I pull on it, there's internally a pulling force. The normal force can therefore be a compressive or tensile force and always runs in the direction of the longitudinal axis of the body in question. The bending moment is next. The cuboid is supported and has a cantilevered end. When I apply a force to this free end with my hand, the foam block reacts by bending. The more force I apply, or the greater the cantilevered length, the greater the bending moment. Bending, or the bending moment, is the product of the force multiplied with the lever arm. Finally, there's shear force. Shear forces run crosswise to the longitudinal direction of the body in question. To explain it, I imagine a cut through the body. I therefore use a cuboid which is cut into two parts, but please imagine that this is only one. One end is now resting on the truss and the other end is protruding beyond the edge. If a force is applied very close to the cut, the two cut surfaces move against each other. The shear force thus causes shearing off against each other. A pair of scissors does exactly the same thing with a piece of paper. The upper blade presses down while the lower blade presses up. However, the paper is so thin that it cannot resist the force exerted by the blades and is severed. I have now explained three different internal forces. However, there are actually 6 internal forces on a three-dimensional body. These are the normal force, the vertical shear force, the horizontal shear force, the bending moment around the horizontal axis, the bending moment around the vertical axis, and finally the torsional moment, which is a bending moment around the longitudinal axis. In the next video, I'll explain how and where these internal forces can be found in a truss.